Hey guys, it's Mrs. McDaniel. Sorry to miss our second day back, but I can't be here today, so I decided to make you a video that you could watch, and hopefully it will help you get through these notes. They're pretty short, um, and we'll talk a little bit more about perpendicular bisectors. If you recall, um, in the perpendicular bisectors yesterday, we were just basically talking about one perpendicular bisector, and how that perpendicular bisector theorem, how these sides would be equal distance from each other. So today, though, we are talking a little bit, we're going a little bit further, and we're talking about what happens if we bisect each of the three sides of the triangle. So, and it's kind of cool what happens. It causes a point of concurrency when you bisect all three of the sides. So what you're basically doing is you're cutting each of the sides in half, and then they meet at a point in the middle. And if you look down here, you'll see on the very first example, that point of concurrency here would be point D. So a triangle has three sides, so it has three perpendicular bisectors, as the second bullet says. And these bisectors are concurrent lines, and the point of concurrency of the perpendicular bisectors of the sides of a triangle is called the circumcenter of the triangle. So this is actually called the circumcenter. And then there's a circumcenter theorem. It just says the perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. So it is equal distance from each of the vertices. So if you look down here, BD would be the same distance as AD, which would be the same distance as CD. So in some of these, there may be some easy solutions, but in other of these, we need to remember a theorem that will help you guys today, which is the Pythagorean theorem. It's going to help you solve a few of these. So I want to write that at the top here so that you have that. The Pythagorean theorem, if you guys recall, is a squared plus b squared equals c squared. And this is the Pythagorean theorem. And we will need it sometimes today because in right triangles, we can always find a missing side. If we know two of the sides, we can always find that third side by using a squared plus b squared equals c squared. And as you can see in this very first example, there's lots of right triangles because of these little squares that indicate they're right triangles. They're right triangles because they're perpendicular bisectors. So, and perpendicular means that it forms a 90-degree angle. So let's take a look at the first example. We've got three examples to get through, and then one that y'all are going to do on your own, and you can check to see if you did it correct. So it says find DC if D is the circumcenter. So I'm just going to kind of highlight what they're wanting us to find. They're wanting us to find this right here. So it says find DC if D is the circumcenter. It says AC equals 9. So they're telling you that AC, which is actually this full distance, is 9. So I've got that on there. Oh, how do I make that triangle go away? There we go. So AC is 9. And then they tell you that DE is 1.83. So this little guy right here is 1.83. And I'm not sure why that keeps showing up. Hopefully it'll go away. Here's the deal. When I'm looking at this, there's nothing that really on there that can help you just say, hey, I know what DC is. DC is the same length as BD, which is the same length as AD or DA, whichever way you want to say it. But they didn't give you those. So we can't just find the answer that way. So we're going to have to use Pythagorean theorem. What I do know is that 9 is the entire distance of AC. But if I knew EC right here, I would have a little right triangle that I could find DC with. So EC is half of AC. So what I'm going to do is I'm going to take this 9 and I'm going to divide it by 2, which is 4.5. Because that distance right there has to be 4.5. So now you have two sides and you want the third. So this is where you use the Pythagorean theorem. So we can say 1.83 squared plus 4.5. I'm going to erase that mess I got going on here. Plus 4.5 squared equals c squared. So that's that a squared plus b squared equals c squared. And it does say round to the nearest tenth. So I'm going to go ahead and put this in my calculator. And I did this all at once. I did 1.83 squared plus 4.5 squared. And I got 23.5989. And you can put that in your calculator and see what you get and make sure that you are putting, especially in my blue calculators, that it's calculating right. So 1.83 squared, we use the little caret button for the squared, plus 4.5 squared, and then just hit enter after that. You should get 23.5989. And if we want to find out what c is, not c squared, we want just c, which is this length right here, be the length of DC. We are going to square root this side and square root this side. If you square root c squared, it's just going to give you c. And if you square root 23.5989, it will give you 4.9 rounded. Okay, so that's what I get on that one. And again, I use that Pythagorean theorem. The first thing I had to do was cut that AC side in half because it had been bisected. Bisected means it cut it in half. So it was 4.5 and we had the short side DE and we were able to use that Pythagorean theorem, which is going to be very similar to these other ones that we're going to look at. So let's look down here at QS. It says, find QS. So here's QS. And again, if they would give you PS or RS, you would know the answer. But they don't give you that. They want you to find QS, and instead they give you QR. QR's right here. And they tell you, hey, this whole thing is 7.79. And then they give you SV, which is this little guy right here. And SV is 1.70. And again, they have not given you enough information for you to just say, hey, I know QS. But what we do have is we have a little right triangle right here. If we knew QV, we could find QS. Well, we don't know QV, but we do know QV is half of QR because it's been bisected. So I'm going to go ahead and put in my calculator, and I'm going to divide that 7.79 and divide it in half, or divide it by 2. And it comes out to be 3.895. So I'm going to write that down, 3.895. Okay, so now that I know that, I can then use the Pythagorean theorem because I have 3.895, and if I square that plus 1.70 squared and set that equal to c squared, I can find that missing value. So what I'd like you guys to do is to take a second with your calculator and go ahead and put in 3.895 caret 2 plus 1.70 caret 2, meaning squared. The little caret is this little sign on most of your guys' calculators. And then see what you get, hit enter. On my blue calculators, you would hit enter. And make sure that you get the same thing I got, which is 18.061025. And that should equal c squared. That is not the answer because we just want the value of c. We don't want c squared. So we will square root this side and square root this side. So you can just hit square root 18.061025 and you should get 4.2 for your value of C. Okay. All right. We're going to look at one more. You might be moving kind of fast, so if you need to pause the video, you can write all of that down. And again, you may want to draw in your little triangles so that you can see them, so that when you do some homework or practice on this, that you can see those triangles and why we're using the Pythagorean theorem. I'm not just using it because, I'm using it because it always helps you find missing sides in right triangles. So, all right, the last one says, find MQ. So I'm going to go ahead and mark MQ. MQ is right here. It's that side. Ooh, that's a pretty wide line. Let me go back and use just this red. So MQ is right here. Again, MQ is the same distance as ML and MJ, but they don't give you ML and MJ. So we're probably going to have to use Pythagorean theorem again. They gave you MN, which is 5.6. So this was 5.6 right here. And then they gave you JQ, which is this whole distance of 13.3. Okay, so again, since they gave you the whole distance, that doesn't help you because you just want to use one of these small right triangles to use the Pythagorean theorem. However, you know that N is the halfway point of JQ because that side has been bisected in half. So we can take 13.3 and we can divide it by 2. And when we do that, we get 6.65. So that means NQ is 6.65. So now I have enough information to use that Pythagorean theorem again. I'm going to do 5.6 squared plus 6.65 squared equals C squared. And now I'm going to go ahead and put that in my calculator using my calculator. And again, you should get a pretty large number because I know 5 squared is 5 times 5, which is 25. And I know 6 squared is 6 times 6, which is 36. And I know it should be bigger than 25 plus 36. So it should be bigger than 61. So when I got 75.5825, that seemed like a reasonable value to me. So I'm going to go ahead and square root that and square root the right side. And I end up getting 8.7 for C. And remember, when you're finding this long side over here, which is called the hypotenuse, which is across from that right angle, it will always be the longest side. The hypotenuse is always the longest side. So 8.7 seems reasonable because it is bigger than 5.6 and 6.65. I do want you guys to stop the video and go down. Sorry, I'm drawing all over here. And try it on your own problem. You can ask the sub or one of our lovely paras to help you and make sure that this is right. But it is very similar to the ones that I just did. So you will likely have to find half of one of the sides and then use Pythagorean theorem. So try it yourself, see what you get. And then if there's time, the sub will be giving you some more practice. We will talk to you guys soon.